Hi folks, welcome to another episode of NYC CNC. Let's thread mill on the Tormach PCNC mill today. It's something I've always wanted to do, and I picked up one from Maritool here. This is a double angle chamfer cutter, 3/8 with a 60-degree included angle. And what I want to do is expand a little bit off of the Tormach video tutorial that they did on it. It's not bad, but it doesn't cover, in my opinion, quite everything. And I thought it would be fun to make a sort of real part, if you will. What I thought would be great is I've got an AR-15 here, and the buffer tube I think is a great example of a part that is a candidate for thread milling. It's a 1 3/16 inch by 16 threads per inch thread. We're going to make a little nut here, but everything we're going through would be the exact same if you were actually going to be machining the lower receiver buffer tube threads. I don't have a bare one of these right now to work with, so we're just going to make a nut. So let's just confirm here. I'll show you on our thread gauge, the 16 threads per inch one here, that matches just fine. And if we grab a set of calipers, you know, about 180, 182. The minor diameter, which isn't always the most accurate way to read this, is, there we go, about 125. I took a look in the, it's funny, I always call it the machinist's handbook. It's apparently actually called the machiner's handbook. Anyways, the specs for a 1 3/16 by 16 thread, the major diameter has a range of 176 to 186, and so we're within that, and likewise the minor 120 to 134, so we're within that too. So here is our cutter. Let's though hop over first into a Libre and take a look at the nut, and then sprue cam, which is where we'll do most of the real work here. Here's our nut in a Libre. We'll take a look at the dimensions. Now I just mentioned the sort of 180, 182 major diameter. I found in experimenting with this that you actually want about 190 to get the right fit. So that's the reason for that. And then I took a quick look to make sure we've got about 93 thou at the thinnest part of the nut, which is sufficient. And we'll come back to this outside diameter here in a second when we look at the workpiece in sprue. Now I've already got it all designed up here in sprue. Let's take a first look at the 5D machining, and then I'll come back and show you the rest of the code. We're actually going to delete this and start over for you so we can see it from scratch. So we'll go to roughing, hole machining 5D, and first thing we're going to do is create our workpiece, and that's one of the little tricks here. We're going to click on the workpiece and primitive, tube, round part, that's all fine, and click add. We don't want to mess with the other stuff here because if you end up trying to tweak it, you'll add more. It's better to add, close. Now we can double click on it and we'll be actually changing it versus adding another one. So it's drawing a diameter around the whole part. Now we know from a Libre that this is 1.588, and we know we want it to actually be the 190 and inside of that. So all we've got to do is very basic subtraction, which is 1.588 minus 190 gives you 398 divided by 2 is 199. So we will decrease our outer radial by 0.199. Click OK. And sprue cam doesn't do a very good job of showing you this, but if you see from that blue hue, there is a workpiece inside of this 1.19 inch ring there. Now we want to thin that out so there's only 32 or so thou thick. We know that because our major diameter is 190 and our minor is 125. So that gives us 65 thou divided by 2 is 325. So what we'll do is simply do interradial 0.0325, click OK, and now you can see a much better defined blue ring around the part like so. We click on the measure and you can see, get rid of our cutter here. If you click, it's odd to me that you click on the area here, it doesn't give it to you, but if you click on the inside you can see the stock of 325, and it's the same number that's stacked over some other numbers right there. So we've got the 325 that we want. Now the other thing you can do, which I definitely prefer sometimes when SpruitCam is not cooperating, and that may be my own just lack of experience with the software, but you can actually just create this workpiece geometry in a Libre. I'll show you just like so. Just create a sketch with your 2 dimensions, extrude it out as needed, and then all you do in Sprue is click on workpiece, then do file, import, and import that IGES, and it will create the same workpiece for you, which can be very convenient. Okay, so let's do our settings here. We are going to choose a limited conical mill, call it thread mill. I'm going to use tool 200. Now I'm going to put in Tormach's settings first, and then I'll show you how we measure up our tool to change them. So they had a screenshot of their settings here. Yeah, it was 36, so 0.036, 0.025 diameter, 60, and H was 0.035. We'll zoom in on that and just do a quick comparison to make sure. Yeah, it looks right. Okay, so first, before we change it, I'll show you what they did with the tool holder, which you know, it can be, to me, it's a bit of a brain damaged process. I don't really like how you've got to type in all the tool holder stuff. So I have uploaded the Tormach code if you want to use it. I'm actually not going to use it, but I'll show you how you can use it if you want to. This, sorry, by the way, is on the NYC CNC website. If you click on projects, thread mill, AR-15 buffer tube, you'll see that. I'll format this a little better here after the video's up. So you can add this holder code in. Usually, though, what it'll do is it'll put the holder below the actual cutting tool, which is at the top here. So all you've got to do to fix that is change the overhang, and the overhang is the sum of your dimensions after each colon. So the 0, the 35, the 0.7, and the 0.5. So I did that over here in Excel, and you get 1.235. So we'll type that in, 1.235, and we'll zoom in. Now we're still not right, and that's because we've got to offset it by the length of the tool. So that's 36. So again, if you just add 36 to that, you get 1.271. 1.271, and there you go. Now if you want your full tool holder, you've got it. Like I said, I'm not going to use it. But what I do want to do is measure up our tool and change this to match the one we're actually going to use. So all we need to do is, we know it's 3/8 in diameter. We'll measure the height, and this doesn't have to be dead nuts. So I'm happy with that at, let's see here, 88, so we'll call it 90. And then what's the flat area here? That's a little less. We'll call it 80 maybe. So let's adjust our diameter to 375. Our length we said was 90, and our H was 80. Okay, yeah, it looks about right. I'm sure there's a geometrical relation here. Yeah, if you make your H, actually I guess if we make it 90, it'll thin out to 0, so that's fine. Okay, so per, oh, that's fine. Make sure it's the same here. Per G-Wizard, I'm doing this as a woodruff cutter, 375 tool diameter with 6 flutes. In aluminum on a conservative cut is 3100 at 17. So we will do 3100 at 17. And then strategy is where all the mojo is. Spiral, thread milling. We're going to do longhand. Thread depth is the, what we already said, 0.0325. That was our dimension right here. And we're going to do a spiral step. It's 16 threads per inch, so it's just 1 divided by 16. We're going to do it in, say, 4 passes, be very conservative. And we will come up to 0.1 and a safe of 50 thou. So that should be good. Now all we need to do is choose our workpiece. And make sure we're on the model here. There we go. Center and run. Okay, so let's see if that looks right. Simulation. Speed it up here. Perfect. Okay, the other machining operations to make this part, I'm going to drill through with a 1/2-inch drill because I don't like plunging with my rougher. We're going to rough the outside with a 1/2-inch corn cobber. Same with the inside, and then we'll do a finish pass on the outside, finish pass on the inside, and chamfer the edges. A couple of quick notes though. When we rough the inside, remember this geometry that we see here in the solid model is the major diameter. We actually need material in 32 thou to serve as the meat of the threads. So when we rough this, we're going to leave plenty. We're going to leave 40 thou, and then when we finish pass it, we're going to leave 32 thou. Technically, we should leave 32.5 thou, but I'm okay shaving off 5/10 of the thread tips there. And then on our chamfer, I am certainly not the first to do this, but the trick I like to do is it's a 30 thou deep chamfer. So we're using a 90-degree engraving. We're using a 90-degree end mill, and what I'll do is go down 40 thou and over 10 thou, and what that does is it cuts not on the tip of the tool. And you can see here, this will be, it'll do it a roughing. You can see it's cutting on the side of the tool, not the very tip. So, okay, we'll do one simulation through the whole thing and see how it looks. There's the drill, the rougher. Roughing out. We're roughing all the way through, by the way, so that we have plenty of room for our threading tool to go down. And finishing there, and then our chamfer, and finally the thread mill. Okay, looks good. Let's hop over to the mill. Okay, let's clean out our vise. Okay. We're only going to be cutting a 1/4 inch deep, and what we'll end up doing is flipping the part over and machining the excess off. I should have 3/8 left. So what we're going to do is just clean up the top with the Superfly to give us a nice surface finish, and we don't even, and we'll reduce the amount of cutoff. So give us a nice surface finish and reduce the amount of cleanup we've got to do on the other side. Okay, and we can honestly just eyeball the center. Okay, I do a quick sanity check. Yep, that's about the right height, and we're entering our rougher off the side of the part, which is good. And I'll fix my coolant lines for the drill, and let's make some chips. That's my mistake. I had that previously set to peck, and I forgot to change it back. You usually do want to peck those so you don't have the bird's nest build up like that. Okay, here's the moment of truth. I'm going to do a quick sanity check. Yep, that looks good. Okay, adjust the coolant lines a little. And off we go. Some people, would say this is boring. I tell you, I could watch this for hours. I think it's the coolest thing. Hell, I like watching most machinery work, but watching it interpolate threads like this is beautiful to me. Okay, now before we move the part out of our vise, I'm going to go grab the buffer tube and we're going to test our fit. Sweet. Oh, that's awesome. Oh, it's such a good fit. Okay, I'm totally happy with that. That's all the further it'll thread in because we obviously have some unthreaded meat below it here. So I'm going to go take the piece out of the vise here and I'm going to cut off some of the excess with the bandsaw, and then we're going to machine the rest away and we'll have our nut. Be right back. Okay, cut the excess around it. Let's first, we're going to measure the height of our measure the height of our parallels, and we'll set that to negative 0.25, and then we will know how far to machine our part down. Sorry, I didn't have the microphone on there. Well, we set our 0 to the top of the parallels, and actually we set that at negative 0.25. So now we are going to just put our part in the jaw, and we will know how far down to machine. Actually, let's okay, got a roughing end mill back in. Tool 11. Now we don't have a ton of surface area gripping the part here, so we're not going to go crazy. Okay, final pass. Okay, it was out of focus the last time. So give it a shot here. Perfect. It's definitely snug, but I don't think it's too tight. like so. So I think that's pretty cool. Super easy to do. As you can see, it does take a little bit of a knick-knack in sprue cam. There are also some wizards in Mach 3. I haven't used them, but folks speak highly of them, so definitely don't want to discount the value there. But got to say, pretty happy with that. And honestly, it doesn't take long at all to do, which is really cool. So on that note, if you guys have enjoyed this, please do me a favor, comment, and give it a thumbs up. Otherwise, that's all I got for today, folks. Take care.